Okay, today I want to talk about the fundamental theorem of calculus, and there's actually two parts, part 1 and part 2. We already know how to do part 2. I've just never told you what it was called before, and I'll get to that. But part 1 shows the relationship between the derivative and the integral, and that's what we're going to focus on today. But part 2 is the formula for evaluating a definite integral. So this part 2 is what we already know. Let's say we have something like, take the integral of 2 to 3 of x dx. Well, all that is you're just going to, we know the formula is going to be take the derivative of that, x squared over 2 to 3. This is part 2, which is the formula and the process of how to find the definite integral. So that's going to be 9 halves minus 4 halves, which is 5 halves, and that would be the answer. Okay, but what we're going to talk about today is how to show the relationship. So what if I had y equals the interval of 0 to x let's say it's 8t dt. So what we want to do is we want to find dy dx. We want to find the derivative. Well, here's my y over here. So if I need to take the derivative this side to get dy dx, then I'm going to have to take dy dx on this side of 0 to x of 8t dt. So the relationship is basically that the derivative and the integral are going to cancel each other out. And we're actually going to be able to just replace this x, because we want it in terms of x, and this is in terms of t. So basically, all we have to do is take this x and plug it in for t, and our answer is 8 sub x, or 8 times x. Okay? Now, really what it is whatever this function is, let's just go with t, and I'm going to say a box and then triangle. And then so basically all you do is you're going to substitute in for t the box times the derivative of the box minus the triangle times the derivative of the triangle. Most likely this bottom number, like 0, will be a constant. And what's the derivative of a constant? The derivative of a constant is 0, so this term always just most of the time will just disappear. Let me give you an example. So let's say we have, pause for a second. Okay, let's say you're asked to solve this equation using the fundamental theorem of calculus part 1. Okay, basically I'm just going to find the derivative of both sides. Well, I'm going to get g prime of x equals, well, because I'm going to take the derivative of this side and I'm going to take the derivative of this side, the derivative cancels out that integral. And I'm going to just substitute this x in, and I'm just going to get 1 over x to the third plus 1 times the derivative of x. Well, the derivative of x is just 1, so I don't have to do anything. Plus, and then I could substitute in 1 to the third plus 1 times the derivative of 1, which is 0. So that I don't really care about. When this bottom number is just a constant, it's just going to be multiplied by a 0, because the derivative of a constant is a 0. So the answer is just this portion right here. Okay, let's do a couple more examples. Let's say we have, I want to find g of r, and I have the integral from 0 to r of the square root of x squared plus 4 dx. Well, I want to now find it in terms of r. Okay, why do I always get this blurry thing? Okay, I want to find it in terms of r. So I'm going to take the derivative of this side. Well, if I take the derivative of the left side, I have to take the derivative of the right side. The derivative and the relationship between the derivative and the integral is that they cancel each other out. They're inverses of each other. So all I have to do is basically just plug that in here. So I'm going to get r squared plus 4 times the derivative of r, which is 1. Okay, so I'm done. This is my answer. It makes it really easy. Okay, let's look at something like this. 1 to the square root of x. Let's say we're going to find g of x equals sine of t dt. Okay, so again, I'm going to take the derivative of the left side, and when I take the derivative of the right side, it's going to cancel that out. I want it in terms of x, so I'm going to just take that x and plug it in here. So I'm going to get sine radical x times, now I have to take the derivative of that. What is the derivative of x to the square root of x? Well, that's the same as x to the 1/2. So when I take the derivative, I get 1/2 x to the negative 1/2, or I can write that as 1 over 2 times the square root of x. So I multiply that times 1 over 2 times the square root of x, and when I simplify that, I get sine radical x over 2 radical x equals g prime of x. Okay, there's my answer. All right, one more. Let's see, what if I go from x to 2x, and I have, I'll just stick with g of x equals t to the third dt. Well, we're going to go through the same process. I'm going to take the derivative of the left side. When I take the derivative of the left side, I have to take the derivative of the right side. That's going to cancel that out. So I have to take this and plug it in here. So I'm going to get 2x to the third times the derivative of what that term is, minus, now this is not a constant on the bottom, so I have to plug it in. So I'm going to get x to the third times the derivative of this, what's in this box down here, or this triangle. So this, let's simplify this. This becomes 2 to the third is 8. 8 times 2 is 16x to the third minus x to the third. So I get g prime of x equals 15x to the third. That is my final answer. So on page 306, all you're doing is finding the derivative of the left and the right. For the most part, you're just plugging in the top interval into the equation like we did in these problems here, right? Plug the r in. Here I had to plug the radical x in, but once I plug the radical x in, don't forget to take the derivative of that top term. And if the bottom term is not a constant, you're going to plug in both the top and the bottom. It is that simple. Any questions, we can go over them when we see each other in class. Have a great day.